Hey, good evening, everyone, and thank you for joining another NYJavaSIG event. I hope you're going to enjoy this event, and please use the chat to ask as many questions as possible. If you're your first time here, we would like to know it, so please use the chat and let us know if this is your first time. Also, please let us know where you watching from. I would like initially to thank our sponsors. So here's JetBrains and the Agile Learner from the Great Venkat. And they were nice enough to give us some prizes to raffle. So we're gonna be raffling tonight 2 JetBrains license. It can be used for any of the JetBrains products. And we also gonna be raffling a 1-year subscription to the Agile Learner website. There's a lot of good content over there. If you want to participate, the rules are simple. We're going to be posting a form that you need to fill. And also you need to be here during the raffle to receive your prize. Okay. Just one more thing. We're going to be trying something new tonight, a post-networking event. So at the end of the event, we're going to also be posting here the link with to Zoom, a Zoom meeting. We're gonna, depending on the number of people, we're gonna split people in different rooms. But the idea is just to talk a little bit. So if you would like to join, please stay with us. We would love to know more about you. Right? I'm gonna introduce tonight our guest. So Andres, he's a Java champion, works at Oracle. He's a very nice person, but if you want to get him mad, all you need to say is Maven clean install. Don't do it, please. But today he's not here to talk about Maven. He's here to talk about Layrry and the JPMS, Java Platform Module System. I heard that we're not supposed to say the whole name, I think. You can explain better, Andres. So Andres, I would like to thank you very much for being with us tonight. I know it's already past midnight for you. Well, thank you very much for being here with us. The stage is all yours. Thank you.
Thank you very much, Rodrigo. And welcome, everybody. Thank you for joining us today or tonight. I'm going to share my screen and then put the slides quickly. So here we go. Now, the idea of today is to showcase some of the APIs and features coming from the Java Platform Module System. And some of those features can be used with a brand new project called Layrry. Now, so as Rodrigo mentioned, my name is Andres Almaray. I work for Oracle. I'm a Java champion alumni. And one of the things that we do in the team that I'm working inside Oracle is, well, we work with the database, surprise, surprise. But we create a lot of projects and products that happen to be on the open source side of things. So what we do is we promote those things and we talk to you developers to figure out what need to be changed, what things could be added, and we just come back and try to make our things much, much better. So if you ever have any problems with our products, if you want to know more about the open source projects that we do, just feel free to reach out to me, and very, very happy to engage. Okay. So as we said earlier, JPMS, it actually stands for Java Platform Module System, but apparently the Java architects do not like this name. So we should not call this JPMS. Sadly, we cannot use we should not be using the acronym. We just should call it Java Platform Module System. Yeah. So that there is no confusion with any other module system that exists inside the whole Java ecosystem. So what is this thing? I mean, perhaps you have seen the platform system before, but if you have not, you may know it from a different name. Back in late JDK 6, there was this idea to break down the JVM monolith into smaller pieces. And it was done under the project named Jigsaw. And the finalized version of this project came out in Java 9, which should be close to 3.5 years ago, if I'm not mistaken. So while the architects and the Java team were working on breaking down this monolith, they came up with a series of APIs that helped them achieve the goals. But the way that they saw that the APIs were helping them, they thought, perhaps it makes sense to bring this API closer to the surface and allow us, developers, to take advantage of those APIs so that we can define and we can design our projects, our APIs with much better encapsulation. At least that is the goal. So that's what was released 3.5 years ago with Java 9. We know this as the module system, and it has some really neat capabilities. The idea is that if you have a module descriptor, then you can export packages and you can skip exporting certain packages so they become private. They will never be visible to the outside world unless you either export them or mark opens for reflection. You can also define service interfaces that can be loaded using the service loader API and a few other things, right? So this being said, there were some concerns, or there are still some concerns if you ask the developers. So this, you may have seen them, you may have gone through them, or you may know someone that has said something about this. First thing first, the modules in the Java Platform module system are not versionable. They don't have a version. The specification says you should not apply a version because we don't have any way to define a version on a module. As a matter of fact, if the name of the chosen module ends up in something that looks like a number or some sort of version number, then the compiler will tell you, will emit a warning right now. It's like, you should not be versioning your numbers, your modules. Another thing that the Java Platform module system does allow you to do is load or change modules at runtime. The way that we assemble applications with modules, it should happen at compile time, because the compiler can check if all the packages and all the services that should be exposed are actually exposed properly, are reachable, there are no conflicts within one package or the other, and it will tell you your application is sound, so you can continue, assemble, and run, or it will break and it will tell you what is making your project break, and then we should go about our business and fix this thing. But we cannot do this at runtime. We cannot load new modules at runtime. You also apparently have to modularize all your dependencies. That means you should have an explicit module descriptor. That means placing module info Java in your sources and compiling it in order to reap all the benefits of the Java Platform module system. Why? Because if you have a full module descriptor, you not only have the name of the module, but you also have all those constraints that you really want to expose, which packages are visible, which packages are hidden, which service APIs should be exposed to the service loader, and a few other things. Okay. It's also hard to map a dependency, but a dependency, I mean pretty much an artifact jar, to a module, because the way that we currently consume our dependencies, whether you use Maven, Gradle, or any other Java build tool, we pretty much rely on the Maven POM format that defines the group ID, artifact ID, version, classifier if you need it, and that's it. But there is no correlation with what module may be inside that particular jar. The specification right now actually doesn't say that there must be a module per jar. That could change in the future. But right now, it's just a convenience that there has to be one module per jar. Yet we don't know how those group ID, artifact ID, version coordinates may map to a module name. And finally, even if you have non-exported packages, then you can still have the problem of what is known as a split package. While we're working on the class path, and this has been something that has happened in several projects, you may have a package name that it's found in 2 or more different jars. This is known as a split package. And again, the class path, this works, no problem. But in the model path, we're supposed to have just one package name per module. If we don't, then we're going to have trouble. All right. So based on all these things that I have said so far, I'm talking about modules and versions and loading classes at runtime unloading and all these different constraints, you may be thinking, well, Andres, this kind of sounds like this, isn't it? Shouldn't we just be using OSGI because it solves these problems, adds a few others, and then also adds some other features? Yeah, perhaps. But this is not a talk about OSGI. This is a talk about the Java Platform Module System. So here's the thing. When the API was released in Java 9, there is a particular class that we have access to, which is called a module layer. And a module layer, you can think of it as kind of like a collection of modules, and you can establish a hierarchy of module layers in such way that modules on one layer will be able to reach out to modules on another layer. So if you built out the cluster in a specific way, then your application should be able to work, and each layer will provide some sort of isolation for just the modules inside that particular layer. And that's exactly what we are going to showcase today. So if you were to browse to the Java doc of the module layer class, you find something like this. And you could create a class loader per module layer with as many modules per layer as you want. Or you can create multiple class loaders per layer. It's up to you. Here's how the API for the module layer looks like. This is what you have access since Java 9 with nothing else, right? This is coming from the standard library. So we create an instance of something that's called the boot layer. So this is the base layer, and we use the system class loader with just bootstrapping how we're going to create our application. And notice that on lines 4 and 5, we provide paths to archives, to jar files, that should contain the modules that we want to use in our application. Then on lines 7 to 13 is where we assemble the modules using some sort of configuration. Notice that in line 12, we refer to the module names. So this is one of the problems that we saw earlier, mapping that particular module name, com example foo, to an artifact artifact coordinates such as foo100 jar does not happen by magic. We have to know this, so that's why we put it in the code. And then on the last line, we bootstrap everything with just one class loader, which means that if we want to instantiate classes from the full layer instance, then we can reach out to all classes exposed by com example foo and com example greet. Okay, it's quite straightforward when we have just a handful of jars and we have only a handful of modules. But if you start to assemble a much bigger application, then of course this is going to grow. Here's another thing that we can have a look at. Say, for example, you have an application. We're going to use this notation of group ID, artifact ID, and version number for our like a module version. So we have an application in the com example app version 1 module, which depends on two other modules, foo and var. And foo and var have a common dependency, which is log4j API, so that's fine. But notice that foo depends on greeter version 1, and var depends on the same module, but a different version. Now, if we were to assemble an application as is with the standard module layer API, then this is going to break. Because the compiler will tell you, you have a split package. What can we do to solve this particular problem? Well, this is where Layrry comes in, and this is where Layrry offers solutions to some of the problems or concerns that we noted earlier. So Layrry is the brainchild of Gunnar Morling, a fellow Java champion. He works as an open source engineer at Red Hat. He is the lead of the division project. You might have heard this, the change data capture. And he's also the spec lead for Beam Validation 2.0. He likes to blog at morling.dev. He is very, very approachable, and he is a really, really good open source engineer. So he started this project, Layrry, as a matter of fact, a year ago. It's about this time last year when he announced to the world that Layrry came out. So the example that we saw from before, that particular diagram with the application and the conflicting modules, here's how we can solve that problem using the Layrry API. Using the power of layers, we can assemble layers with different modules. So we start with the base module, which will be log, that contains the log API, the log4j, and some log configuration, which is specific to our application. And that's it, just 3 modules. Then we have the next layer called foo, with 2 modules, greeter version 1 and foo. And notice that layer foo has a parent that is the layer log. That means that the foo module can look at everything, every class, every service exposed by the log layer. Okay, so we're going 1 level up. As a sibling, we have the bar layer. Similar to foo, it depends on log, it's a parent, and it has modules bar and has module greeter version 2. So that will be the key difference. Finally, we have the layer app, which assembles both foo and bar. So that is the topmost layer. And it adds an additional module, which is the one that contains the main executable or anything else. We build this thing, and now we get something called layers. Layers is a Layrry API. And from the layers, we can run a main class and pass any parameters as needed. So this is basically it. So Layrry is a tiny, tiny abstraction on top of the big API provided by Java Platform Module System. So it's just a little bit of syntax sugar in order to consume the module layer API and a few other things exposed by the Platform Module System. Okay, so when we look at this, when we go back to this code, again, if we have just a handful of modules, then the code doesn't look so bad. But one of the things that will quickly should pop up is that the definition of those modules actually are gap coordinates, like shorthand gap coordinates for group ID, artifact ID, and version. And where else do we see these gap coordinates? Yes, in our build tools, in our build configuration files, so POM.xml, build.gradle, whatever that thing is, right? So there is repetition here. There is a potential of having an outdated configuration or missing a number or doing something that might not be the best thing that we should be doing. So is there a way that we can try to reduce duplication? Yes. We can have external configuration. For example, here is the same application, but in this case, defined using external configuration using the YAML format. So the same number of layers with the same name, same dependencies, and same modules. So this should work exactly the same. But if you are like my friend Bruno, you know that the YAML perhaps is not the best format that we could be using because it has significant white space. It's very easy to mess it up. What if there were another expressive format that we could use that does not rely on significant white space, such as Tunnel, which Bruno likes as well? So it so happens that Layrry provides support for both YAML and Tunnel out of the box. And you can hook in any other external format, another passive if you want to. So if is JSON the format that you want to use, you just need to provide an implementation of the config passive. Or it may be XML, or it's any other format. So that's easy. Provide an implementation, hook it in, and off you go. One more thing that we can look at this thing is that even though we're now externalizing this into some other configuration file, we still have that problem of duplicating the version numbers or the group IDs or the artifact IDs that are coming from our build files. What can we do to solve this particular duplication? Well, we also allow parameterization of the config file. So here is an application, which is the one that I'm going to showcase today. It happens to be a JavaFX application because one of the features that I'm going to showcase is making a very compelling example. But know that you can use Layrry with any kind of Java application. It does not have to be desktop-based or JavaFX-based. So what looks here is a little bit weird with those braces. Those are variable placeholders or value placeholders. So JavaFX version, project version, TilesFX versions, those will be values that are coming from some external file, so a secondary external file. And notice the other name called OS detected JFX name. These are very specific to JavaFX, just because when you run JavaFX, the artifacts must be related to the particular platform you're running on. So it's either macOS or Windows or Linux. So this classifier has to be resolved in some way. Layrry is aware that there are classifiers for JavaFX, unlike with Juggle gaming library, and will generate or actually will detect those names and will inject those values when needed. So the only thing that we need to do is know what is the actual name that needs to be used. In this case is OS detected JFX name, and apply it whenever we need it. The second input file is a properties file with any name you want to. Just have to follow the properties format. And every key is just a value. Well, is the name of the value that you want to use as interpolation. So notice that projects version and JavaFX version, TilesFX and Layrry version, all those names are used in the placeholders for the JavaFX TOML source file. Right. Eventually, we can put these two together and have Layrry launch our application. And speaking of launch, how do we launch an application like this? Well, so Layrry not only has the capability to define layers using programmatic API, but also provides ready-to-go launcher. The latest release of Layrry is version 1.0.0 Alpha 1. We released it in January 30th of this year, of 2021. And so you can go right away and download the -all jar, which is an Uber jar or fat jar that contains all the dependencies. So this is the launcher. Or you might want to give it a try to the zip file or the tar.gc file, which also contains all the required libraries and a script launcher. So it's up to you. We have some choices. So say that you choose the shaded jar. So this is how you can launch the previous example. Just run it with Java, pass into parameters, layers config, and properties, and any other additional parameters that might be needed, and off you go. Or if you're familiar with SDKman, which is a package manager for Java-based tools, then you can also use SDKman to install the latest version of Layrry, and then just run Layrry like it is. It's just like if you had downloaded the zip file, and that's it. So the nice thing about SDKman is that as we continue releasing newer versions of Layrry, SDKman can help you download much easily the versions and keep track of how you can upgrade or downgrade from one version to the next. If you don't want to install zip files, you can also give a try to the latest version or the snapshot version of Layrry using another interesting project called jbang. So jbang really brings to the surface the power of Java scripting. So I'm not talking about JavaScript. I'm talking about Java language as a scripting language. You can install it in many ways. You can use Homebrew, or you can use Chocolatey if you're on Windows, or you can also use SDKman to install jbang. Or you can, I believe there is a way that you can install jbang using an URL. This is quite interesting way to bootstrap it, but you can do it. The point is that once you have jbang, you can point it to a particular jbang catalog. Jbang catalog is a GitHub repository, a public GitHub repository that contains certain instructions. And this particular catalog, the Layrry catalog at the Moditech GitHub organization, knows how to provide the launcher classes for the latest snapshot of Layrry. So the first part of the command is different, jbang and the catalog, and the next pass of the command is exactly the same as you were invoking the Uber jar or invoking the binary zip file or the binary distribution, as a matter of fact. So it's just like that. So you have choices in order to run Layrry. So let's talk about one thing. So far, We have seen that Layrry allows you to define gap coordinates for resolving artifacts and mapping those artifacts to modules. Now, those artifacts have to be downloaded from somewhere. That somewhere will typically be a Maven compatible repository. So Maven Central, it could be Maven Local, it could be your organization's artifact manager repository, whichever product you want to choose, you name it. But what if you wanted to build the application and ship it in such a way that say, this is the set of all the jars that I want to use, and they are packaged in this zip file, so they are local to your application. And you don't want your application to use the network to resolve dependencies for, I don't know, reasons. There may be very valid reasons to do so. So this is what is known as local repositories. Layrry offers you the choice to say, besides externalizing your configuration, you can supply the set of jars which are located somewhere in your local file system, so that when those two things are put together, the application will bootstrap. So in order to do this, you can use, well, the programmatic API. You can use also the external configuration files, where we add a few bits more of configuration. Say, if we were to use the YAML format, then we add this notion of the resolve section with a list of local repositories. The name of your repository could be anything you want to, in this case, shows as repo name. You have two layouts that are supported. I'm going to showcase right now in just a moment what kind of layouts we have, and the path to the repository. This could be a relative path. If it's a relative path, then it's relative to the layers file. Or if it's an absolute path, when it will work anywhere on your system. So the two layouts that are supported: the flat repository layout, where all the jars are found in the same directory. This is the easiest one that you can get by copying dependencies from Maven, or do the same thing with Gradle, and you copy all the outputs from a configuration. Or you can have the default repository, which is kind of like the repository format that Maven Local uses. But in this case, we only keep track of the jars. We don't keep track of POM files. There's no additional metadata. The nice thing about the default repository format is that it's very easy to determine that we have a version number that is plain, or we have a version number with a classifier. Because actually, that's a little bit of a typo. There's an extra 0 on the version number in the default repository. But if that were to be correct, then it was very easy to identify that there is a version. If we had a classify in the flat repository, we still have to crack open the jar and look into a special metadata. If it's found and it is that correct, then we can definitely detect if there is a classifier or not as part of the version number. So say, for example, -snapshot or .ga or .final, whatever those things, if we're not paying attention, that could be interpreted as a classifier instead of part of the version. That's what I'm trying to say. So,
can you use a local Maven repo and turn it into your default repository?
Yes, you could have. You could copy files from your Maven local repository and locate them through the hierarchy and place it where it needs to be. But I do believe that Maven, the Maven dependencies plugin, is Maven dependency, or maybe another plugin that will give you the capability to generate a repository like this. It might be the app assembler plugin. And for the case of Gradle, there is no default plugin that does this. I mean, you could do it with some Groovy or Kotlin DSL, but the Core and Gradle plugin suite has a task that will allow you to generate either of those two layouts as well.
Okay, and while I've interrupted you, a question from a little back. Do you know if jbang leverages JSR 223 scripting for the Java platform?
No, it does not. Actually, it used to leverage something called the JEP 330 added in JDK 10, which is known as Launch from Java Source. The idea for this JEP is that you have a single source file that may contain more than one class. And when you want to run that particular class, then you use the Java interpreter, just the Java command. You don't compile it. And what happens is that the classes get compiled on the go and then get executed. That's a nice idea for testing out some theories as long as you don't require any external dependencies. And that's the problem that jbang solves. The way that you can define external dependencies as part of a special comments in your source file so that you could have a full-blown database script that can process data in and out in just plain Java with being a self-contained script, for example.
Cool, thank you.
Sure. So we know that now we can resolve dependencies from any Maven compatible repository. We can also resolve dependencies from your local file system if you want to, with or without access to remote repositories. What if we want to go the other way? What if we want to put everything on the network? What if we want to put our configuration files also on the network? And the only thing that is going to be local to you is the launcher. Yes, we can. We have this feature called remote layers. And the idea of the remote layers configuration is that you may have your layers file and your properties file if needed. They can be hosted anywhere on any remote location. So pretty much HTTP or HTTPS server. You can mix them both. So you can have local configuration plus remote properties or vice versa, both remote or both local. So we support all combinations. And there's one thing that I'm going to say about dynamic plugins, which is something that I have not said so far, but right now the current restriction is that all your plugins must be local. And now you may be wondering, what is this thing about plugins? And the feature that I'm going to showcase today is the one that sold me the idea to have a deeper look at Layrry. It's not just the fact that we can assemble applications with conflicting versions of the same modules or conflicting classes. We can also have something called plugin architectures. We can add and remove modules at runtime, which means our application can gain behavior while it's running, or it can lose that behavior. If this sounds familiar, it's because that is what IDEs do for us. Though some of the IDEs require a restart in order for that behavior to kick in, even though, well, they use OSGI. But in this case, it's much simpler than that. Layrry offers one interface, just one, that you can implement on your application in order to be notified when a new plugin gets added or when a plugin gets removed. So that will be this interface, a plugin lifecycle listener with just two methods, plugin added, plugin removed. And the plugin descriptor contains a reference to the layer that was created using the jar and the modules that provided by the plugin. And when you want to remove it, you can also get a reference to that layer and see what you can do. Now, typically, implementations of this interface will use the service loader interface if what you want to do is load services. So it could look something like this. Once we hook into, let's say, some plugin was added, we just make use of the service loader utility and load everything that is coming from that particular module layer for a type that it's under your control. In this case, the type is called my service. It's very, very important that you use this version of the service loader load method, the one that takes a module layer as a secondary input, a secondary argument, because if you do not, chances are you are not going to find the type that you want to. And finally, while we're iterating over all the instances found by the service loader, we still have to check if the instance is loaded from the layer that you want to. Because if you have a hierarchy of layers, the service loader will find all the instances across all layers. And we're only interested in instances coming from a very specific layer. So, I mean, this is a little bit of hassle, but it is what it is. So again, at this point, I think that I have said too much about theory. Let's get into practice, shall we? Okay, so let me show you the application while it's running. I have an application here. Again, it's a JavaFX application, and you can choose anything that is not JavaFX in order to run this. Now, just to be extra sure, yes, I'm going to do a clean here so that there's nothing up my sleeves. And I'm going to clean my local repository, not everything because I'm not crazy, but I'm going to make sure that there are nothing installed for tiles. Okay, good. Just going to be sure that that's this way. Perfect. So now what I'm going to do is compile my classes, my application, and I need to install the jars in my Maven local repository. Otherwise, it will not work. So I'm going to try different variations of this. So the first thing I'm going to do is install this. So we're using Maven, and it goes through all the different modules. And it will finish in just a moment. It doesn't take really that long. It's actually generating Javadoc. I could have skip that pace. That path should be okay. So now I have the following directory that has been generated with a handful of files, external configuration files, and some directories. If I were to look inside the staging directory, it looks like this. Again, we have some configuration files. We're going to see in a moment what's going on with all this. There's an empty plugins directory. It's another directory that contains a handful of files in different formats in a flat repository when we want to try that particular version. So our plugins are packaged as a jar. That means it's just that plugin and no dependencies. Or it can also be packaged as a tar.gz or as a zip file, in which case we allow additional jars so that if your plugin requires other dependencies or other modules, that you can put them all together inside either of those two. But if you were to use the jar format, we expect that to be just those bits. It may be a shaded jar if you want to, but it cannot contain any other embedded jars. Okay. So I do have Layrry installed using SDKman. So when you launch the latest version of Layrry, it gives you this output for help. You can also tell me which version of Layrry I have. I believe should be a snapshot. That is, because if I look at Layrry in SDKman, it tells me the following. I have two versions, the official one, which is 1.0.0 alpha, and the one that I use to install locally for development. Why I'm using a snapshot version? Because the remote layers functionality that we shipped in alpha 1 was not working correctly with proxies. So there is a fix already in the snapshot, but it's not yet released. Okay, I'm going to run the application for the first time. So we say Layrry, layers config, and we pass one of those files. Oh, actually, I should show you the configuration first before I do that. Let's look at this one. It's the same contents as we saw earlier in the slides. It is two layers, the JavaFX layer that contains all the JavaFX artifacts, the core layer or the app layer that contains the dependencies of my application, the modules of my application, and a plugins layer. The name of the layer could be anything. I just chose plugins. The directory that is going to be watched by Layrry could be any name. I just chose plugins. That's it. And versions, pretty much the same versions that we saw before in the slides. So now that we have this, we can run this. I can say Layrry, layers config, staying layers.toml, properties, staying versions properties, pops a window that looks like this. It's an empty window. Okay, I'm going to put it in the background. And now, watch what's going to happen. I'm going to copy from a directory that is not being watched by Layrry, so plugins prepare. I'm going to copy the clock plugin into staging plugins. And the moment that I click enter, Boom. The application reacts to a new plugin being added. You can tell that this is live because I'm streaming from Switzerland. I'm 6 hours ahead of you. I can do the same for the other plugins. For example, I can put in the tile gauge, and let's use the zip file and put it in plugins. There it goes. I can copy the last one, plugins prepare called tile sparkline, and let's use the targc in this case, plugins, and there it goes. If I want to, I can remove from the plugins directory tile sparkline, which is the last one. Oh, let's remove the one in the middle. Gauge, like this. What? That's strange. Okay, maybe I broke something. Interesting. The plugin should be gone, but it's still there. Ah, we may have a memory leak here. If I kill the application and launch it again, like we did before, should show only 2 plugins. I must confess, I was fumbling around with the code yesterday evening. I may have done something to break it, but trust me that if it was very easy for me to say to trust me, right? If I were to do this, whoop, that's not CP, RM it. It should be gone, but it's not. So I definitely broke something with this application. The point is that if I remove a plugin, then this visual element should be gone, but it's not. And that actually goes to showcase, well, it will showcase one of the things that I want to talk about in just a moment. But before I do that, let's kill this application. And let me show you the next thing. I'm going to run everything locally. So I'm going to remove from my local repository every reference to the core DAM tiles, like this. So delete everything, right? So it's gone. And if I use a different launching file, so what is it, layers local, the only difference that we see from the previous configuration file is that now we'll reference the flat repository directory that we had before, right? So again, there's nothing on Maven local. This application is not published to Maven Central, so there is no way that I can resolve dependencies. If you don't believe me, let's try launching the application again, as we saw before, and it should break. Yeah, could not find artifacts in Maven local. Perfect. Let's fix that. Let's use a different configuration file. Let's use the local one. And now the application continues to work because we already have a plugin there, the clock plugin. Perfect. Let's kill that one. And finally, I want to show the remote layers. And for that, I have this file published on GitHub. And I have the version properties if I want to. There's one step that I need to be doing, which is if I showed you the local version for that file, which is layers remote. The way that this thing is configured, I will use a settings XML file that will tell me where I can download the artifacts. So I need to copy from here into staging. And if I showed you that repository, that file looks like this. I have 2 servers that I can use to resolve dependencies. Maven Central and GitHub packages that is bound to my particular account. And right now, if you want to read from GitHub packages, you need authorization. So you have to pass a token. I'm not going to showcase my token, of course, so it's part of the environmental variables. And these particular files are found in these packages. So what I'm going to do now is try to read the jars from this package. Okay, so what's going to happen now? I'm going to launch Layrry, passing layers config will be the reference to this file. I can use the local version properties if I want to, or can use the remote. And one last thing that I need to do is specify the base directory. This is for locating the plugins directory, because otherwise it would not be found. So I say that it's a staging, and I put it in the background. Notice that there are some errors by trying to resolve from central, yet the application works. This happens because I listed central first and GitHub packages repository second. If I were to embed this, then the no warnings will appear because the resolution will happen on GitHub packages first. So it depends on how you configure your application. You may or may not get these kind of warnings. Then you can see now the application continues to work. So how do we make this happen? We can have a look at the source code. Here is the basis for handling plugins when they get added or when they get removed. A plugin for this application implements this particular interface. This is an interface that is under your control. This is nothing related to Layrry. You can do whatever it needs to be done. The only thing that is specific to Layrry is an implementation of this interface. So we grab the layer for the plugin. We grab all the, or we resolve all the instances for that particular interface. We filter them using the particular layer that we're interested in. And once we have that, we pass it into, again, another application-specific class called plugin registry, which will know once it has an instance of that type plugin, how it needs to create the UI objects that need to be added to a particular UI container. And when a plugin gets removed, then this other method gets invoked. And again, it goes through the plugin registry and passes in the module layer. And this plugin registry keeps track of all the plugins based on layers. And when one thing gets added, it will know what to do. And when it gets removed, it will know what to do. So we could drill down, further down into how this thing is done. But now we are again crossing the realm into what is specific to your application. So the way that you will handle plugins is up to you. One thing that should not be forgotten is that this service implementation must be registered. We can look that here into our particular project. So we provide this interface from Layrry for a custom implementation. So when Layrry boots up using the launcher, it will find all the implementations for this interface, will do the registration and when it needs to be done, and then notify you when something gets added or removed. And this is basically how it works. Are there any questions at this point? Before I go back to the slides.
No questions, everybody's good.
Okay, all right. So I fumbled the plugins. I need to review why it didn't work out. But that actually is a nice segue into a problem that we had in the past. Apparently, it has resurfaced, which is memory leaks. If we are adding and removing classes at runtime, there is a much higher chance that something may not be unloaded at the right time, and then we will be leaking references. That's a memory leak. Okay. So that's kind of exactly what's happening right now. I think that's the kind of the problem. There is a notification that is missing. But in order to kind of solve this particular problem, at least give you the tools to find where the problem may be, Layrry relies on Java flag recorded events, or JFR for short. So whenever a plugin layer gets added, we will record and trigger a JFR event. And when a plugin layer gets removed, we also record and trigger a JFR event. So using the Java mission control, if we were to inspect the events generated by the modular tiles JavaFX application that we saw, we can have a look at a series of events here when a new plugin is added or a new plugin gets removed. So we only have 3 plugins in this case. We can use this information to match with other events that mission control can keep track of, such as class unloading and class loading. So when we see the correlation within the events published by Layrry when a plugin gets added, and when classes get loaded, and when a plugin gets removed, and when classes get unloaded, if we have the same number of events and there is a proper correlation, then things are working correctly. If there is not, then there's likely that there is a memory leak. So we can continue to have a look at, and when Gunnar did an investigation on the modular application that we saw, we found out that we had dangling classes. We got dangling references to the UI widget. And the reason for that is that you saw that the UI widget had some animations. And in order to do that, it spawns a thread. Turns out that that thread was not being shut down at the proper time, and that kept the UI reference alive, even though we thought that we had unloaded the classes. So by doing this investigation, we figured out that we needed to shut down the thread. We added the code to our application, and now there is no particular memory leak for that particular use case. If you were to continue going using mission control, well, you could drill down and use a profiler to do anything that you want in order to try to find all those dangling references. But the point being is that if Layrry did not give you those JFR events, it would be a little much harder to figure out where and when things were happening. One thing that we may be doing in the future is enrich the JFR support that we have in Layrry in order to provide additional events that may be of interest. And speaking of which, what is coming up in the future for Layrry? Well, we want Layrry to be available anywhere where developers would like to have access from. That means that if using the shaded jar or downloading the zip file directly from the release page, or using SDK man is not enough for you, would you rather use Homebrew or Snap if you're on Linux, or Chocolate if you're on Windows, or something else, then yeah, we're going to provide an option for those as well. Another thing that we may be doing is providing this kind of self-contained distributions. So even though we can have, we can define a layers file that says, I want to use all these jar files that are local to a repository, flat or default. What if we're to package all those things in some sort of artifact? I don't know, maybe a jar, maybe a zip file that is self-extracting, self-executable, and embed a specific launcher that will just execute your application. Say that you package all the zip files and then just publish it on a server. And either you download that zip file or just point a specific launcher to that zip file, and then that downloads everything for you and off you go. This is kind of like the capsule deployment. Or you may want to use a custom JLink image that comes with some predefined set of modules already baked in. And then you just point to a layers configuration file that supplies the additional modules needed for your application to be run. What if we wanted to really reuse the configuration for your POM file that has all the dependencies and the coordinates for your own projects, and use that to generate the layers configuration file? We still don't know yet how that can look like, what kind of integration will be needed, but that's some of the ideas we're looking at. What about having access to the Layrry API from within your application? Right now, the only thing that you do is register a lifecycle listener. But if you want to have access to the layers config file, or want to have access to the layers instance that was created based from the config file or the programmatic API, for whatever reason that your application may need to, then you should be able to do so. And we will figure out a way to make that happen. I already mentioned that we may be able to also publish additional JFR events. Or if any of these features do not sound something that is interesting to you, maybe you have some other ideas, we certainly welcome you to reach out and talk to us and let us know that maybe there's another interesting feature that we have not considered yet. And we just start a discussion. We start a conversation around it and see how far we can take this idea. So let me remind you, Layrry is open source and you can find it at the Moditech organization on GitHub. The JavaFX application that we saw today is available from the Layrry examples repository. There are two other examples. The full example that we saw before, or the greeted example with the conflicted modules, is also found there. And there is also a serverless example using Vertex, for which you can have also dynamic plugins. You can add routes or you can remove routes for your particular Vertex application, so you can have more or less behavior. I have to say, confess that we have tried Layrry with the popular microservices web framework projects that you find out there, such as Spring Boot, Micronaut, and Helidon and Quacos. And it wasn't until yesterday, Micronaut 2.40 came out, they were successfully able to launch a single layer application with Micronaut. It has to do with a few issues that they have with some dependencies that expose modules using split packages. So they fixed that. Now, we were not able to run it with the other frameworks because some of them do not support the module layers API directly. So once you are running module layers, you have to use class loaders in a little slightly different ways. And I kind of show that when you recall an interface using the service loader API, you have to pass in the layer if you have a layer. If not, then you have to do something else. So this particular way of using these APIs must be retrofitted into all these frameworks. It's my hope that that will happen at some point, but the reality is that so far, the only thing that we have been successfully able to test running with Layrry in a modular way is Micronaut 2.40. We have a few other resources, a couple of blog posts. Gunnar announced the project, I said about like a year ago. So the first blog post is when he announced Layrry to the world and what's the idea behind Layrry. Basically, provide an option for resolving modules with conflicting versions. And the plugin architecture is the second blog post when he goes in much further detail on what the plugin system is for Layrry, how you can make use of. I just show how you can do it with JavaFX. The third blog post is the investigation that he did on memory leaks, and he showcases the tools and the reasoning behind it and everything that he does. So that's a very interesting read as well. And the last blog post is from myself when we announced the first release of Layrry with all the features that come in that particular release. So everything that we saw today is open source. If you have not contributed to open source before, let me tell you, it's very, very simple. You find a problem with anything that you saw today or any other open source project that you consume in your daily work, file a ticket. And you find that there is something missing, there's something that's not working properly, or there is a new feature, interesting feature that could be added, file a ticket. That's it. You don't have to provide source code. If you want to, sure, provide a test case. If you have the time, you have the passion, provide code if you want to. But at the very least, just file a ticket. Just telling the people at the other side of the wire that you're using the project and you find a problem and you have an idea is plenty. So just do that. And well, you don't know, maybe you become a contributor. Maybe you start out your own projects. You don't know exactly where open source will be able to take you. I started 16 years ago in Mexico City and now living in Switzerland, just thanks to open source. So that's it. I think that's all that I have right now for you. So I guess if you have any questions.
Sounds like it's time for questions.
Yes.
We're going to alternate the announcement of winners with questions to get everyone to pay attention. The first winner is of an IntelliJ license, Dave, H-R-E-C-Z-A-N-Y. I don't know how to pronounce that. It's got a lot of vowels, but congratulations. Say hi in the chat. And our first question is, since Layrry permits dynamic module loading, does it mitigate the need for OSGI? Does it provide a complete solution to jar hell, but more simply than OSGI?
Yes and no. Reason being is that OSGI is a specification, and it comprises not just dynamic module loading and export packages and all those things that the specification provides, but many other things. So maybe some of those features are really needed by the application and the projects that you're building. And well, Layrry does not provide any of those features. The only features that Layrry provides at the time are those that I showcased today. Now, are those features enough to do what needs to be done for your project? Well, we have to evaluate. Are all your dependencies modules in some way? Maybe it's automatic module names, or you have an automatic module name in the manifest, or you have a full module descriptor. Then it should work out of the box. If you have any split packages in any of those dependencies, you may need to change it, because I believe that it doesn't work right now. So that's kind of like a hard requirement. And if that is the case, if you only require launching dynamic plugins and loading, then Layrry could certainly do the job.
Okay, thank you. Our second winner, also of an IntelliJ license, is Ari Meyer. Congratulations, Ari. And our second question is, does the Layrry launcher work with GraalVM native compilation?
We've been looking at that, and out of the box, it does not, because there are two issues right now that are being working on. GraalVM does not yet, the native image does not yet support modules. That's something that I'm currently working at. And the second one is, oh, and I missed my train of thought. If you want to do dynamic loading of classes using native images, well, you can't, unless you run Java truffle on native image, which is also recently supported. I mean, it has been supported for quite a while, but the GraalVM just announced new enhancements to really run Java as a dynamic Java classes on top of a native image that in itself could also has been a Java program originally. So again, that was kind of like a long answer. The short answer is we still have a few things to figure it out, but that's definitely something that we're looking at.
Okay. Winner number 3 of the Agile Learner subscription is Hilmer Chona. Congratulations, Hilmer. And the next question is mine. It's about modules, not Layrry specifically, although it's possible Layrry makes things easier. Back before modules, it was common when writing JUnit tests to put them in the same project and use package private access to make things easier. That does not appear to be the ideal way to do it with modules. What would you advise people to do?
Right. Interesting thing. So the thing is that if you either use Maven or Gradle, and if we keep using that particular idea to have a parallel directory definition in both in production code and test code, then you will quickly figure out that for running your test cases, you need to open the module. So you need to add opens, add reads, or patch the module in order for test cases to reach this. Now, it can be a little bit cumbersome to do so in your build configuration file. And for this reason, Christian Stein from Germany added a couple of features for both Maven and Gradle. So he supplied the capabilities so that you can define a module info.test file. It's a simple TXT file that has the same syntax as a module info Java file. And Maven is able to pick it up and do the automatic patching and exposing for you. So it takes out all the hassle. It is as if you were patching your module info with test support.
Cool. I'm going to have to try that out. it looks like we have reached the end of the Q&A. So I'm going to turn things over to Rodrigo for some closing remarks.
All right, thank you, Jean. Thank you very much for everyone who attended the session tonight. Jean will be posting here in the chat the link to the network event. If you would like to attend, would love to know more about you. If you have anything you want to talk to us, can be tech related or not, you are very welcome to participate. Andres, thank you very much for being with us tonight. It's, I don't know what time, it's 2:30 a.m. I think for you. It's very late. Thank you very much. It was very nice to have you here. I hope you come back soon. And if you want to be notified about NYJavaSIG next events, follow us on the social media. Okay, our website javasig.com, and here on Twitter at NYJavaSIG. Thank you very much. I hope to see you in the network event. Goodbye.
Thank you very much, everybody. Thank you.